Welcome to learning Program 102C on the IBM Selectric Typewriter. The objective of this program is to present the technical information covering the construction, the operation, the maintenance, and the repair of the dual pitch feature. This means that upon successful completion of this program, you should be able to repair, adjust, and maintain the various mechanisms which make up the dual pitch feature on Selectric typewriters. The materials needed for this program are the standard office machine repairman's tool kit with the special tools for servicing the IBM Selectric Typewriter and a Selectric typewriter equipped with a dual pitch feature. The IBM Selectric Typewriter is a serial typewriter. The Selectric Adjustment Manual and the Service Manual are also needed. The Adjustment Manual and the Service Manual are copyrighted property of IBM Corporation, and the use of their drawings has been made possible by courtesy of IBM Corporation. The photographs, recordings, and all the supplementary materials are copyrighted property of Audio Visuals Universal Incorporated, Los Angeles, copyrighted in 1978. 10-pitch mode typing means that the typewriter will produce 10 characters per horizontal inch of a typing line. Conversely, the 12-pitch mode of operation produces 12 characters per inch. For 10-pitch typing, each escapement action allows the carrier to move by 2.54 millimeters, and in 12-pitch typing, each escapement action produces 2.12 millimeters of carrier movement. Obviously, the pitch selection mechanism affects the movement of the carrier. This means that any mechanism which causes carrier movement of any kind will automatically be affected by the pitch switch lever. This enables us to organize the checkout procedure for the dual pitch mechanism, since the mechanisms which cause carrier movement are printing escapement, spacebar escapement, tabulation, backspacing, and carrier return. Since the advent of the Selectric II, the machines also come equipped with a half backspace lever and the express backspace key, which should also be inspected in connection with dual pitch mechanism checkouts. Even the most casual investigation of the operation of the pitch switch lever, or selector, reveals that the movement of the lever branches into 3 different directions. At the point indicated by the green pencil, changing the position of the switch pitch lever alters the position of the escapement rack. At the point indicated by the yellow pencil, it alters the position of the margin rack. At the point indicated by the red pencil, the switch pitch lever is connected to a control cable, and as you trace the control cable to the right side of the machine, you will find that through it, the switch pitch lever has the ability to change the position of the backspace pawl. When the switch pitch lever is moved toward the front, the escapement rack, the margin rack, and the backspace pawl must be in the 12-pitch position, which means that the typewriter should now operate in the 12-pitch, or elite, mode. Conversely, when the switch pitch lever is in the rearward position, all 3 mechanisms are switched to the 10-pitch operating position, and the typewriter will operate in the 10-pitch mode. Take a few minutes and observe the parts movements resulting from changing the switch pitch lever on your machine before continuing. When it comes to the tabulation mechanism, the manufacturer has presented us with a compromise since the machine has only one tabulation rack. Notice that the indicated tab rack stop lugs are not spaced evenly. The stops are arranged in a repetitive pattern of 6 stops per group. While this tab rack allows us to use the same rack for the 10 or for the 12-pitch mode of typewriter operation, whenever we switch the pitch, we must clear all the previously set tab stops and set new stops for the newly selected pitch. This represents only a minor inconvenience, but it is most important that every technician be fully aware of this when he discusses the matter with the operator. There is no assurance that the operator still remembers that this is how the tab stops are to be used on dual-pitch typewriters. At this point, remove the feed rolls from the right side of your machine and also the right side dust shield, as we have done here. It is a good idea to use rubber bands in order to prevent the feed roll support levers from interfering with the movement of the carrier whenever the feed rolls have been removed from them. As an alternate solution, we could also leave the rear feed rolls in place. Please tie up the feed roll support levers on your machine. To let us examine the structure, the shape, and the operation of the various parts of the escapement mechanism, let us temporarily and partially disassemble the tabulation mechanism. Loosen the indicated screw until the clamp becomes completely free on the tab rack shaft. From the indicated screw, disconnect the restoring spring for the escapement trigger support bridge and the nut which holds the overthrow stop for the escapement trigger support bridge. Needless to say, removing the nut breaks an adjustment. The overthrow stop should be positioned at 1/10 of a millimeter from the trigger support bridge when the escapement mechanism is at rest. Disconnect the spring indicated by the blue pencil, and then remove the screws indicated by the green and yellow pencils. Now move the platen detent control lever, indicated by the yellow pencil, toward the front of the machine to remove the detent roller spring tension from the shaft of the tab rack at the point indicated by the red pencil. After this, you should be able to extract the tab stop rack from the machine. Be careful not to use any force if you find an obstacle. Locate the obstruction, then remove it or avoid it before you continue. Without the tab rack, it is actually very easy to take a real close look at the escapement rack. While observing the escapement rack in this manner, you should operate the pitch switch lever. You will discover, for instance, that the escapement rack is round for the most part and held in position by the carrier rail. On one side the rack has pica teeth, and on the other side, elite teeth. You will notice that there are 6 elite teeth to every 4 pica teeth. The contour of every 4th pica tooth is completely round in order to provide adequate support for the rack. For every tooth in the elite escapement rack, there is a stop in the tab rack. When the machine is used in pica mode, for every 4 teeth in the escapement rack, there are 2 stops in the tab rack which will never be used. For as long as the machine is used in pica mode, the tabulation rack has 33% more tab stops than it actually needs. With the margin rack, the situation is practically the same. The margin rack is also round, with pica teeth on one side and elite teeth on the other, and through the action of the pitch switch lever, it is possible to rotate it. Again, a round rack like this must be properly supported, and this is accomplished by what is now called the margin rail. The margin rail supports the margin rack and the margin stops. While you're at it, you should again examine the effect which the pitch switch lever movement has upon the backspace Pawl controls at the indicated point. As you examine the indicated part, you will find that it is actually a cam. It is called the pitch cam. On dual pitch machines, IBM calls it the backspace Pawl driver. This is the upper end of the backspace Pawl, or driver. When you observe the shape of the backspace Pawl from the inside of the machine, you'll find that the upper end contains either a pin or an offset portion, as in the case depicted here. The pin, or the offset portion of the Pawl, is directed toward the rear of the machine, and it rests on the profile of the backspace Pawl control cam, or pitch cam, which we saw a moment ago. Again, take a few minutes to examine this before continuing. On dual pitch Selectric typewriters, the backspace mechanism is called the rotary backspace mechanism because it uses a ratchet and the carrier return and backspace cable to accomplish it. To assure reliable backspace operation, the carrier return cord is now a steel cable. The source of power for driving the backspace operation is the carrier return engagement, or indexing, cam. The backspace latch, or backspace selector latch, is placed beneath the carrier return engagement and indexing cam follower by the backspace interposer, and then pulled down by the follower. The backspace lever, or bell crank, will then rotate down on the right and up on the left, where it also pulls upward on the backspace driver. The driver uses a portion of this motion to engage with the backspace ratchet, and the remainder of the motion to cause top-to-right rotation of the ratchet and the carrier return cable drum, thus pulling on the cable so as to cause leftward movement of the carrier. Be sure to check out the shock absorbing feature under the carrier, and take a moment to study the nomenclature of the various parts contained in this drawing. We mentioned that the carrier return engagement and indexing clutch drives the backspace mechanism on Selectric II typewriters. This makes for a total of 3 different functions which are driven by the same cam. You will recall that this clutch cam requires 360 degrees of rotation for each operation, since it has only one lobe. This cuts in half the rate of repeat backspacing on the Selectric II typewriters. Since this clutch cam now has 3 functions, it is necessary for the selection mechanism of the machine to also have the operating logic to make this possible. We know from single pitch machines that the mere operation of the carrier return engagement, or indexing clutch, caused at least indexing to occur. Carrier return engagement had to be selected, so to speak, using the carrier return selector latch. This is still so on the dual pitch machines, unless the indexing mechanism is purposely disengaged. This means that the machine will produce indexing upon the mere engagement of the carrier return engagement, or indexing clutch. It will produce carrier return engagement and indexing when the operator selects carrier return engagement. The clutch will be able to produce a backspacing operation if and only if the backspace mechanism has been selected through its own selector latch, and if the indexing mechanism has been filtered out or disengaged prior to the operation of the clutch. There are already two versions, or levels, of the mechanism which filters out, or prevents, the indexing function from occurring during backspace operations. When the mechanism is at rest, it is important that there be a clearance of 1/4 of a millimeter between the paddle in the drawing on the left, the so-called interlock shaft in the drawing on the right, and the stud on the linkage which connects the cam follower to the index transfer bell crank. When the backspace selector latch moves toward the rear, the link, colored yellow, will be pushed toward the rear of the machine also, over the slot in the indexing transfer bell crank. Look this mechanism up in your machine and determine which level mechanism it is and whether the adjustments are set up correctly. To let us better see the various parts of the escapement mechanism, let us also remove the tab stop set and clear plate. Let us start by disconnecting the trigger spring indicated here. Be sure to remove the spring from the machine completely and store it in a safe place, since it is very easy to lose the spring inadvertently. Now remove the tab stop set and clear plate by loosening the indicated screws. There is no need to remove the screws completely. Retighten the screws after the removal of the set and clear plate. Now position the carrier on the right side of the machine so that you can observe the escapement from the rear of the machine. The escapement pawl is located immediately above the yellow pencil. What may appear to be complex is in reality simpler than on the single pitch machine, since the dual pitch escapement mechanism does not have a backspace pawl. The green and the yellow pencils point at the same part of the escapement mechanism, namely, the support bracket for the escapement pawl. We have disconnected the escapement pawl, restoring spring in order to make viewing easier. On dual pitch machines, the escapement pawl must be kept from developing vertical play of any kind, and it must be held quite firmly in a fixed vertical position, because when the escapement rack is rotated by the switch pitch lever, the escapement pawl must retain its vertical position as closely as possible. It must not be allowed to move with the rack. The maximum vertical play of the escapement pawl is 1/10 of 1 millimeter, which amounts to saying that it must have minimum vertical play and no binds. The lug indicated by the yellow pencil can be formed in order to minimize this vertical play of the escapement pawl. As a matter of fact, it is necessary that the pawl be held in the center of the slot in the carrier rail which holds the escapement rack. On dual pitch machines, the carrier shoe comes equipped with a slot, which allows us to lift or lower the rear of the carrier, and with it, the escapement bracket and the escapement pawl. Notice the number of adjustments, a total of 7, which have to be made every time one changes the adjustment of the carrier shoe on the dual pitch machines. These adjustments are identified by their small red frame numbers in the lower left of this adjustment frame. Make it a point to check out each of the adjustment frames mentioned and explain why it must be made again when one changes the position of the carrier shoe. The quiz at the end of this program will thoroughly test you on this point. Noteworthy is the fact that recent level dual pitch machines no longer have an escapement torque bar backup stud underneath the escapement pawl pivot point. Instead, the machine comes equipped with 2 backup studs fastened directly onto the power frame. This one is located approximately in the center of the machine, and another one is at the left side of the machine. Be sure to locate them and check their clearance with respect to the escapement torque bar. The backup screws should be just touching the escapement torque bar. Let us temporarily disconnect the tab lever spring from the tab lever, as shown. We have also disconnected the tab lever latch spring. there are considerable differences between the single pitch tabulation mechanism and the dual pitch tabulation mechanism. They can, however, be summarized by the statement that the dual pitch tabulation mechanism can be fine adjusted much more easily because it has the needed adjustment capabilities built into the mechanism. The tab lever pawl is spring-loaded on dual pitch mechanisms. This means that once the rest position of the tabulation lever has been established, the tab lever pawl must have its rest position adjusted also. This is accomplished by changing the position of the stop indicated by the green pencil. If, during tabulation engagement, the tab lever pawl should meet a set tabulation stop, the tab lever pawl would rotate right side to the front of the machine, and in the process be guided by the portion of the tab lever located directly underneath the tip of the yellow pencil. The rest position of the tabulation lever latch, when the tabulation mechanism is also at rest, is against the right edge of the tab lever indicated by the green pencil. So far, this is the same arrangement as found on single pitch machines. However, when the tabulation mechanism is engaged, we find that the position of the tab lever latch is against the stop indicated by the yellow pencil, instead of being against the bottom of the notch in the tab lever. When we investigate the operation of the tab torque bar at the lower rear inside of the machine, we find that it too is now controlled much more positively. The indicated point of the support bracket for the intermediate bridge, through which the operator causes the tab torque bar to turn, serves as the fixed point for the angular rest position of the tabulation torque bar. When the tabulation lever is fully depressed, the lower lug of the intermediate bridge stops against the bottom edge of the support bracket, and thus limits the overthrow of the torque bar. Now, operate the half backspace lever while observing the two indicated spots in the machine. In the main picture, we are observing the right end of the escapement rack. Notice that when the half backspace lever is at rest, the escapement rack rests against the end of the slot in the carrier rail, indicated by the red pencil. The insert shows the escapement rack restoring spring, which is located at the left side of the machine. The arm of the spring, indicated by the yellow pencil, causes the escapement rack to try to move toward the right side of the machine at all times. When we pull the half backspace lever toward the front, we must counteract the spring, and when we release the lever, the spring pushes the escapement rack toward the right of the machine again. Now find the indicated escapement rack collar. If you run the tip of the spring hook along the left side of this collar, you will find that there is a step on it. The job of this collar is to limit the action of the half backspace lever, so that when it pulls the escapement rack and the carrier toward the left of the machine, it pulls the rack only the distance corresponding to half of one horizontal space. The insert in the upper left-hand corner shows a protrusion in the side frame. This protrusion is needed to allow the half backspace mechanism to work correctly when the typewriter is in 12-pitch typing mode. When the switch pitch lever causes the rack to turn top toward the rear into the 12-pitch position, the step on the left side of the collar will be placed so that the next time the half backspace lever is operated, it will stop the escapement rack earlier than it does during 12-pitch mode operations. The collar must be positioned angularly so that the step on the left side of the collar faces the protrusion in the side frame when the machine is set to type in 12-pitch mode, and so that it is out of the way of the protrusion when the machine is set to type in 10-pitch mode. On level 1 half backspace mechanisms, the leftward escapement rack movement is obtained through the action of the half backspace bell crank, which acts in a notch in the escapement rack. Notice in the insert that the notch in the rack has a step in it, so the action of the bell crank for 12-pitch mode is not the same as the action for 10-pitch mode. The extra step on the 10-pitch side of the notch produces increased movement of the escapement rack. This increase is just enough to make up for the difference between a 10-pitch half backspace action and a 12-pitch half backspace action. Finally, notice that level 1 escapement racks are pushed toward the left by the action of a compression spring rather than by a toggle spring, as we have seen earlier. For level 1 half backspace mechanisms, the half backspace movement of the rack is adjusted by changing the length of the link, which connects the half backspace bell crank to the remainder of the control mechanism. On level 2 half backspace mechanisms, the position of the half backspace collar must be fixed laterally so that when you type a series of dashes over an already printed series of dashes, this time with the half backspace lever held toward the front of the machine, the spacing between the dashes is even. If you switch the pitch switch lever before adjusting the collar, and if you have the set screw of the collar facing the front of the machine, you will not have to worry further about the angular position of the collar. The angular position will automatically be set correctly. Be sure to study the action of the link indicated by the blue pencil. Its job is to cam the escapement rack toward the left when the half backspace lever is pulled toward the front of the machine. The final adjustment of the half backspace mechanism is the position of the handle for the backspace lever. It must be centered within the slot in the machine cover, and it is changed by loosening the screws located immediately above and immediately below the point indicated by the yellow pencil. Now let us turn to the margin rack. The compression spring indicated by the blue pencil tries to hold the margin stop rail toward the right side of the machine at all times. The margin stop rail and the margin rack are held together through the lug indicated by the yellow pencil. It is important that when the margin rack is pushed toward the left side of the machine by the carrier during carrier return operations, the margin rail also moves to the left side of the machine, and that it does so immediately, without any loss of motion for the margin rack. With all of these discussions out of the way, we are prepared to perform the adjustments of the various mechanisms of dual pitch machines. We will work from the bottom up, following the sequence of the fundamental adjustment followed by serialized secondary adjustments. We will refrain from discussing adjustments already covered in the study of single pitch machines, except in cases where correct sequencing makes their inclusion mandatory. Our first topic will be the adjustments of printing and spacebar escapement. The second step will be tabulation, then backspace, and finally carrier return disengagement, or margins, as some people insist on calling it. One of the most obviously fundamental adjustments of the machine is the position of the escapement rack, or in the case of dual pitch machines, the adjustment of the carrier rail which holds the escapement rack. Notice the wide opening for the screw which holds the carrier rail to the power frame of the machine, indicated by the pencil. Using the hooverometer on the number 1 scribe line, adjust the position of the carrier rail, front to rear, so that the rail is absolutely parallel to the print shaft, and so that the distance from the front edge of the carrier rail to the front edge of the print shaft is 6.2 centimeters. This distance of 6.2 centimeters is the distance from the number 1 scribe line setting of the hooverometer to the inside edge of the L-shaped tip of the hooverometer slide. The first secondary adjustment of this sequence is the angular position of the escapement rack. But since the escapement rack can occupy 2 different positions, it really amounts to 2 adjustments. With the switch pitch lever in the 10 pitch position, we use the position of the gear against the pivot point of the half backspace lever as the fixed point and rotate the rack until the pica teeth are positioned vertically, as shown on the left. When the gear is finally attached to the escapement rack, it should be placed 1/4 millimeter from the right side of the bracket which supports the rack. This is true only on early-level machines, however. Early-level half backspace mechanisms have a rather roundabout way of accomplishing half backspace compared to the late models. Once the pica teeth have been adjusted so that they are vertical with respect to the base of the machine, we move the switch pitch lever into the 12 pitch position and check for the same vertical condition. This time, instead of adjusting the position of the gear, we adjust the bottom stop of the gear. You should investigate this mechanism on your machine before continuing. On half backspace mechanisms of more recent vintage, the escapement rack must be positioned all the way toward the right of the machine against the indicated half backspace actuating cam. The second secondary adjustment of the escapement mechanism for dual pitch machines is an extremely important one, due to the far-ranging consequences it has on a number of other adjustments of the machine. The escapement pawl must be centered with respect to the slot in the carrier rail. To accomplish this, the entire rear end of the carrier, which supports the escapement bracket, must be lifted or lowered by adjusting the position of the carrier shoe. Very simply, anywhere there is a gap adjustment between any part held by the carrier and any other part held by the power frame, that adjustment will have to be made again after changing the position of the carrier shoe on dual pitch machines. Notice in this drawing that the tip of the escapement pawl extends downward a bit. Without the tabulation stop rack in position, it is extremely easy to observe the exact position of the escapement pawl with respect to the slot in the carrier rail. Because the tip of the escapement pawl of dual pitch machines is extended downward, it is important to take the tip of the pawl, and not the body of the escapement pawl, as the portion which should be centered with respect to the slot in the carrier rail. To obtain the condition shown, we have simply depressed the tabulation bar so that the tip of the pawl is held just outside of the escapement rack, a very convenient position indeed from which to observe the adjustment of the carrier shoe. At this point, practice checking this adjustment. Now to the third secondary adjustment of this sequence. Once the height of the escapement bracket has been adjusted through the positioning of the carrier shoe, it becomes necessary to align the escapement bracket with the tabulation torque bar. As was explained in Program 10.2a, the torque bar has to be parallel to the print shaft before we can be accurate with this adjustment. For this purpose, we check the position of the torque bar in relation to the carrier, first on the left side of the machine and then on the right side of the machine. If necessary, corrective measures can be taken by changing the position of the tabulation torque bar support bracket on the right side of the machine. To adjust the parallelism of the escapement bracket with respect to the torque bar on dual pitch machines, we observe the clearances between the two parts at the indicated points. These gaps should be approximately 1 millimeter, and they should not differ from each other by more than 1/10 of 1 millimeter. In the frame on the left, we recognize that level 1 machines have the escapement pawl mounting stud doubling as the escapement torque bar backup stud. Notice the position which this escapement torque bar occupies on dual pitch machines. On later versions of the machine, the escapement torque bar is backed up by screws mounted directly into the power frame, as we have seen earlier. The screw or stud should just touch the escapement torque bar. And when we make the adjustment, we must make sure the torque bar is kept 1/4 millimeter from the vertical lug of the escapement pawl, as depicted by the circular insert in the frame on the right. This may also require changing the angular position of the escapement torque bar. This constitutes the fifth secondary adjustment of the sequence. Finally, we must bring out a very important point. There are times when there is a discrepancy between the parallelism of the escapement torque bar and the tab torque bar. It may then be necessary to readjust the position of the bracket which holds both, so as to first make the escapement torque bar parallel to the print shaft, and then form the right support arm for the tab torque bar until the tab torque bar becomes parallel also. Needless to say, after adjusting the parallelism of the escapement torque bar, we are required to reposition the escapement bracket, so as to once again place it at the proper distance from the tab torque bar and also make it parallel to the tab torque bar. This means that occasionally we might have to alter the order in which the second, third, and fourth secondary adjustments of this sequence are performed. It depends entirely on the state of the machine before we come to it. A sure way to go about this is to always first check the parallelism of the escapement torque bar, then the tab torque bar, and then the escapement bracket. With the positioning of the escapement torque bar, we have reached a point where the next adjustment is the gap between the torque bar lug and the escapement trigger. All trigger adjustments of the printing and spacebar escapement mechanisms start from the power frame, and only in the end must they hold the trigger at the proper distance from the torque bar lug. This was covered extensively in Program 10.2a. Now let us turn to the tabulation adjustments. After the adjustment of the escapement bracket, we must invariably check and most likely readjust the position of the two indicated lugs of the escapement bracket. The lug indicated by the yellow pencil is the tab torque bar backup lug. It must be positioned so that it is barely short of touching the tabulation torque bar. At its closest point, it may be as little as 1/10 of a millimeter from the tabulation torque bar. The lug indicated by the blue pencil serves as the rest position stop for the tab lever, as you can see just to the right of the tip of the blue pencil, underneath the tab torque bar. The tabulation lever should be allowed to stop at a point where there is at least 1/4 of 1 millimeter of distance between the escapement pawl and the vertical lug on the tabulation lever, which is responsible for holding the escapement pawl disengaged during tab operations. The condition is depicted in the figure on the right. Notice that the clearance is substantially smaller on single pitch machines, as depicted on the left. The escapement bracket position is the fundamental adjustment of the tabulation mechanism. Then, the tab lever stop adjustment and the tab torque bar backup lug adjustment become the first and second secondary adjustments of the tabulation mechanism. In this case, which one is taken first is immaterial. The third secondary adjustment of the tabulation mechanism for dual pitch machines is the tab trigger adjustment. The distance between the indicated lug of the tab trigger and the tabulation torque bar should be 1/10 of 1 millimeter. Now, we must place the tabulation lever into the latched position indicated by the blue pencil and observe whether or not the tab lever latch has the proper bite. When the tab lever latch is engaged with the tab lever, there should be a clearance of 1/4 of 1 millimeter at the point indicated, between the bottom of the notch in the tab lever and the upright lug of the tab lever latch. To adjust this gap, we vary the position of the stop for the tab lever latch. The tab lever latch stop is held in position by the screw indicated by the yellow pencil. This represents the fourth secondary adjustment of the tabulation mechanism of dual-pitch Selectric typewriters. The fifth secondary adjustment of the tabulation mechanism for dual-pitch machines is the adjustment of the escapement Pawl clearance during tabulation. The vertical, or upright, lug of the tabulation lever latch must be formed toward the rear or toward the front in order to hold the escapement Pawl 1/4 of 1 millimeter away from the teeth of the escapement rack. When the tab lever latch is removed from the machine, the escapement Pawl is removed from the right side of the machine, particularly when the tab rack is removed from the machine. Again, take some time and check your machine for this clearance. Now it is time to reinstall the tabulation stop rack. As you fasten the bracket on the right side of the tab rack, make sure you check the parallelism of the tab stop rack with respect to the path of the carrier. The most efficient way to test for this parallelism is to engage the tab lever pawl with the tab stops at the extremes of the tab rack, measure the depth of engagement on both sides, and then determine whether or not corrections are needed. Once the tab stop rack is parallel to the path of the carrier, or simply parallel to the print shaft, we can adjust the angular position of the tab rack. For all fully restored tab stops, the position of the rack should be set so that there is a clearance of 1 millimeter between the bottom edge of the restored stop and the upper surface of the tab lever pawl when the tab lever pawl is under the tab stop during tabulation operations. The fixed point, or anchor point, for this adjustment is the tab set and tab clear lever on the left side of the machine. At this point, adjust the angular position of the tab rack on your machine. This is the seventh secondary adjustment of the tabulation mechanism. Now we can adjust the depth of engagement of the tab lever pawl with the tab rack. The tab lever pawl should be engaged with the tab stop so that there is a bite of 1 millimeter between the tip of the tab lever pawl and the front end, or edge, of the tab rack stop. The adjustment is made by changing the position of the stop indicated. The stop is held in position by the screw just to the left of the tip of the pencil. This is the eighth secondary adjustment of the tabulation mechanism. The lateral position of the tab rack is determined by the nut on the right end of the tab rack shaft. On dual pitch machines, the tab rack should be positioned so that when the carrier is held by the first escapement tooth in the 10-pitch escapement rack, the tab lever pawl barely clears the tab stop when the tab lever is pushed toward the rear of the machine. Notice that the specified clearance is only 0.05 of 1 millimeter. At this point, make this ninth secondary adjustment of the tabulation mechanism. For the angular position of the tab bar, first we use the link, not shown here, at the left end of the tabulation torque bar to position the tab torque bar vertically. Then, we adjust the length of the link which connects the key lever to the tab mechanism so that there is a 1/4 millimeter overthrow for the tab lever after the tab lever latch falls into the notch, as shown in the drawing on the left. This is the 10th adjustment of the tabulation mechanism. Now, reinstall the tab set and tab clear plate so that it meets the conditions shown in the upper left-hand frame. This is not a simple adjustment. Do not be surprised if you have to repeat it a number of times before you get it right. There is a simple way to remember what to look for when checking whether the adjustment of the tab set and clear plate on dual pitch machines is correct. When the dual pitch machine is set to type in 12 pitch mode, the two tab stops which are close together will have to be set separately. When the dual pitch machine is set to type in 10 pitch mode, the two tab stops which are close together are set and cleared together. Beyond these two criteria, we only need to make the plate follow the contour of the tab rack. This is the last adjustment in the series needed to thoroughly and systematically check out the tabulation mechanism on dual pitch Selectric typewriters. Carefully make this adjustment on your machine and then test the tabulation mechanism. The position of the pitch cam, indicated by the blue pencil, is the fundamental adjustment of the backspace mechanism on dual pitch machines, where the mechanism is called the rotary backspace mechanism. Notice the notch on the pitch cam, located just below the point indicated by the yellow pencil. The position of the pitch cam must be such that when the switch pitch lever is in the 12 pitch position, the scribe line or notch in the pitch cam lines up with the center of the stud, or protrusion on the backspace driver or backspace pawl indicated by the yellow pencil. Be sure to verify this adjustment on your machine. If you have to change it, you simply reposition the sheath of the control cable, which connects the pitch cam from the point indicated by the blue pencil to the switch pitch lever. Now place the switch pitch lever into the 12 pitch position, and then, from underneath the machine, check the clearance between the backspace pawl, or driver, and the backspace ratchet at the point indicated by the yellow pencil. As shown in the left frame, this clearance should be approximately 1 mm. The clearance is altered by changing the rest position of the backspace pawl actuating lever, while the crank that holds the backspace actuating lever at rest is located on the inside of the machine. The screws that hold it in position are accessible from the rear, as shown in the right frame. Before you decide to change this adjustment, let us complete the checkout of the remaining adjustments for the backspace mechanism, because this first secondary adjustment of the backspace mechanism is not a very critical one. Ultimately, the rest position of the backspace driver will depend on the results of testing the mechanism, rather than on these somewhat difficult-to-measure specifications. When the operator selects a backspace operation, the backspace selector latch must be positioned under the cam follower, which is driven by the carrier return engagement clutch. The backspace selector latch is indicated by the yellow pencil. It is suspended by the backspace actuating lever, which IBM calls the backspace bell crank, through the nuts indicated by the blue pencil. These nuts allow a wide range of possible positions for the backspace selector latch, as clearly spelled out in the insert specifications. On early-level machines, the height of the backspace selector latch must be set so that under operation, with the machine in 10 pitch mode, the backspace mechanism drives the carrier at least 1 mm beyond the point at which the escapement pawl falls into the space in front of the preceding tooth. Simply stated, the height of the backspace selector latch controls the amount of output motion of the mechanism. Later machines have their specification reduced to the testing procedure, requiring that light left-to-right finger pressure be applied to the carrier while the backspace mechanism is activated and observed for proper operation. Whichever testing procedure applies in your instance, you should test the mechanism for at least 5 operations, since the variation in output motion for this mechanism can be substantial. The clevis, its link, and the crank, indicated by the blue pencil, receive their input motion from the action of the backspace interposer whenever the operator calls for a backspace operation. As the backspace latch moves toward the rear, so do the link and the crank, which transmit their motion through another crank, indicated by the red pencil, to the lower indexing link, indicated by the yellow pencil. When the lower indexing link is pushed toward the rear, the indexing mechanism is deactivated. During carrier return engagement and indexing operations, in which the same clutch is used, it is mandatory that there be no interference with the indexing mechanism simply because the backspace mechanism also uses that clutch. As a result, we must adjust the position of the crank, indicated by the red pencil, using the set screw at the bottom of the crank, indicated by the blue pencil, so that there is a clearance of 1 mm between the lower indexing link yellow pencil, and the crank, indicated by the red pencil. If your machine is of the older style, which uses a paddle instead of the crank, the clearance between the paddle and the pin at the top of the lower indexing link should be 1/4 of 1 millimeter, as we saw earlier in this program. This represents the third and final secondary adjustment of the rotary backspace mechanism. Now it is again time to perform a thorough test on this mechanism. Our last segment of this learning program deals with the carrier return disengagement mechanism. Carrier return disengagement comprises adjustments that are commonly handled in a rather disorganized and spread out fashion under labels such as overbanking, banking, margin adjustments, and so on. On the argument that a name should describe the main function of the parts or the mechanism, the carrier return disengagement mechanism in this discussion consists of the parts responsible for disengaging the carrier return clutch, and the parts responsible for ringing the end-of-line signaling bell and for the line locking mechanism. A natural extension of the adjustments in this department is the overwrite function of the margin release key. The fundamental adjustment of this section on dual pitch machines is the positioning of the margin rack stop bracket. On early-level dual pitch machines, the angular position of the margin rack is determined by the margin rack gear stops, located on the left side of the machine. Today, about all these stops must do is function as overthrow stops during pitch switching. The bracket that holds them, however, must be adjusted so that it holds the switch pitch rack down into the margin rack gear, allowing only 1/4 of 1 millimeter of vertical play. Check this adjustment on your machine before continuing. The first secondary adjustment of the carrier return disengagement mechanism is the positioning of the margin rack. On dual pitch machines, we must adjust the angular position and the lateral position of the rack simultaneously. First of all, notice the remark in the upper right-hand corner of this adjustment frame. On dual pitch machines, the adjustment of the lateral position of the margin rack must be made with the system in 12-pitch mode. Furthermore, at the bottom of the adjustment frame, the adjustment must be checked while holding the carrier stop latch to the right. Finally, you will recall that the margin rack and the margin stop rail are now two different parts. From this frame, we learn that the distance between the stop latch, when it is held toward the right, and the left margin stop lug should be 1/10 of 1 millimeter. On occasion, you will find that in order to make this adjustment, it is necessary to loosen the bracket that controls the lateral movement of the margin stop rail. This bracket is located on the right end of the margin stop rail. We recommend that you first listen to the explanation of the adjustment procedure described over the next 3 slides, and then come back and closely follow the procedure while making the adjustments yourself. Pull the pitch switch lever into the 12-pitch position, and then position the carrier against the left margin stop, as shown here. Then loosen the set screws for the margin rack gear, of which one is indicated by the blue pencil. Notice that the left end of the margin rack has a flat spot, by which we can, perhaps with the aid of a pair of pliers, turn the margin rack until the 12-pitch rack faces the rear of the machine, and until its teeth are vertical with respect to the base of the machine. Then push the rack all the way toward the right of the machine against the stop latch on the carrier, causing the stop latch to be pushed to the right as well. Finally, push the gear all the way to the right also, and tighten the set screws. The gear should now be positioned against the gear stop bracket on the left side of the machine, while the left margin stop rests against the stop latch of the carrier, with the stop latch pushed all the way to the right. This means we have adjusted both the angular and the lateral position of the margin rack. It constitutes the first secondary adjustment of the carrier return disengagement mechanism. As a final step in this sequence, we have the positioning of the margin stop rail, our secondary adjustment number 2. We must now push the margin stop rail and the margin rack toward the left until there is a clearance of 1/10 of 1 millimeter at the point indicated by the yellow pencil. Then, while holding the margin rail positioning bracket at the right end of the margin rail, toward the right against the nylon support bracket, tighten the screw indicated by the green pencil. You will end up with 1/10 of 1 millimeter clearance between the margin stop lug and the stop latch on the carrier when the carrier is at the left margin, and when the margin stop latch on the carrier is held toward the right. Now carry out the adjustments as described, working through the procedure at your own pace. We consider it unnecessary to discuss once again the rather simple express backspace mechanism, and so we can now conclude our discussion of the dual pitch features of the IBM Selectric Typewriter. Nevertheless, we definitely recommend that you also check out the express backspace mechanism, just as you would any other more complex feature. There is never any absolute assurance that the machine will function properly after extensive work has been performed on it until the machine has also been subjected to an extensive and thorough test. We recommend that you do just that at this point. Afterwards, please complete the accompanying quiz questions. We sincerely hope you enjoyed this program, and we wish you good fortune in the profession of business machine servicing. Thank you for your attention.